Greetings, building science enthusiasts, and welcome back to the Building Science Podcast. This week's episode has no sponsor message at all. Instead, I just wanted to take a minute and thank you, our listeners, for all you do to keep this show going. We've got some great episodes coming up on topics like perspectives from HVAC installers, indoor air quality, market change, enclosures, how codes affect building science, chemicals in homes, building materials, etc. And to help to keep the show going, I'd like to ask a small favor of you. There's actually a lot you can do to support us in very simple ways. You could share just a single episode with someone who might be interested. You could even share this episode. You can review the show on iTunes, Google, and Stitcher. You can visit our sponsors and their websites and let them know that we sent you there. And you can even encourage the manufacturers that you know to sponsor the show. We love doing this, and we plan on continuing to do it for as long as we possibly can, and as long as you keep showing up to listen. So thank you again. Please do the very small bit that you can to help us out. And we have an Instagram too, if that's your thing. It's at BLDGScienceATX. So check us out and enjoy the rest of the episode.
Welcome to this. Welcome to the
Building Science
Podcast.
Welcome to the Building Science Podcast.
Bringing the human factor to architecture and design.
Brought to you by Positive Energy in Austin, Texas.
Welcome back to the Building Science Podcast, everyone. Thanks for listening. I'm Christoph Irwin here, as always, with my trusty sidekick, Miguel.
Hey, everyone.
And I'm also here with Brad King.
Hello.
And I should know your company name. Tell us.
Earthbound Builders.
Okay, let's start there. Tell us what Earthbound Builders does.
We really specialize in the use and kind of most valuable applications of locally abundant, natural, minimally processed, low embodied energy building materials. So
right. All right. That's a good list of adjectives.
Yeah. I mean, there's a million ways to describe the stuff, but basically what's here and in large quantities and is easy to get to and to utilize in ways that increase performance and aesthetic quality and the feeling and recently I've been more and more interested, especially in indoor air quality and how those
right.
dynamics affect.
We were talking about high-grid buffer a minute ago. We'll get into that.
Yeah.
So that's the introduction, you guys. You heard that, right? Naturally occurring, locally sourced, low embodied energy materials for building. And I'll just give you a hint. This is not the mainstream trend in building.
Yeah, far.
And if you haven't listened to the episode with Keel Mo from Harvard Graduate School of Design, he is talking about this all the time. He's talking about, in fact, Bill Bram was talking about too, with the embodied energy and materials as being like one of the main metrics we need to think about. Mm-hmm. Okay, so how did you...
just carbon. Thinking in terms of CO2 sequestering materials and how much energy goes into things.
Yeah. In fact, there's a guy named Odom, Howard Odom, did a book called Systems Ecology, and he talks about solar M-joules as a different... It's a different, Earth's environment, it's what's embodied in this energy. Like, so here's a glass right here with water in it. So this glass, it actually was produced with energy that was stored sunshine. Yeah. Right, so that's where he goes to. So carbon and M-joules, solar M-joules, are actually a similar metric, but it's his base metric. Mm. But that's not where this episode's going to go. So first, how did you get started with Earthbound Builders?
Well, I met my partners on a restoration project of a 160-year-old. It's a slip-formed earthen rubble wall system. Just happened to be something that had survived, in Austin. And there were only a couple of sections of the original building still on the property, and it needed a ton of work.
Wow.
Most was primarily the binder in the whole monolithic wall system was like local clay. And there was some stabilization with lime as well. But then we're doing clay plasters and lime plasters and naturally hydraulic lime plasters in some cases on the exterior of it. And
wow. So what is that wall called? What would you call that wall?
It was historically called a slip-formed rubble wall system. Okay. There was a pamphlet circulated in like the 1800s, sometime 1860s or something like that, And there's various examples of it all throughout the West where people had this pamphlet in their, in their supplies or whatever.
Slip form rubble wall system.
Yeah, basically they would lay up courses. They kind of like coil pot the entire building using river rock and mud and clay and lime, depending on the weather conditions.
Wait, could you say what coil pot is briefly?
Yeah, just they're using a form like some sort of board on either side of the wall off of the foundation, adding a bunch of clay bound, and had a lot of silt and sand as well in it, wet material into the form, and then pushing big chunks of rock down. And kind of like it almost forms like a clast bearing conglomerate or something. It's like all the big chunks of rock are loading on each other, but they're just kind of bedded in this matrix of fairly water soluble, vapor open, very kind of natural.
So like a mud wall with rocks in it.
Yeah, basically mud and rocks, and it's arched openings, and it was a big project.
Why do they call it coil pot?
Oh, I said coil pot because if you've ever coiled a pot in kindergarten or whatever, it's pretty much the same process. You just add a little bit to the top of the wall all the way around, and you build the building up. Very similar to cob construction, if you've ever seen books about cob. It's just using a form to contain it all rather than hand applying and sculpting it.
So like a coil of rope makes a little cylinder that you can
Yeah, if you work with clay, you can make little clay pots often you do in kindergarten, first grade or whatever. You take little ropes of clay and you kind of lay them on top of each other and push them together and smush them together, and that's more or less how that building went up, with big chunks of rock in it. We were doing we had to remove sections, redo whole wall intersections and stuff, so there was some load-bearing masonry that was done with it, and there was a huge addition to the project. Anyway, I just was working for a guy here. He was the first person I met that was into natural building in Austin when I moved back here from Washington State. And I had gotten into natural building in Washington State because I was working with homeless youth, teenagers, that were staying sometimes in an emergency shelter in Western Washington that I worked at. And I was also working for a metal roofing company at the time, so I kind of split my time between the shelter and the world of new residential construction, and which is a really weird space to live in for a couple of years. Just in terms of seeing all the social and economic and kind of cultural aspects of the construction world, and then youth that are slipping through the cracks and stuff.
That's intense.
Yeah, and I had kind of I was really interested in just shelter in general. I was still pretty young, my early 20s, and trying to figure out what I wanted to do more with my life, and always loved building stuff. Never was interested in grad school or professionalism in some kind of larger sense. So I just wanted to find a way to build stuff in a way that was useful and that could support myself, and that could provide much needed, healthy, safe, comfortable, kind of passive environments for people that relied less on mechanical systems and expensive bits and pieces that have to go into a new construction. So yeah, and then when I moved here, I found Frank Meyer. He's a wonderful builder. He's been around here for a long time, doing straw bale houses and earthen plasters and lime plasters, and I met him at a workshop that I was volunteering at, and we became good friends, and I worked for him for a couple of years, and then I met my partners that ended up starting Earthbound with me at that restoration project, working for Frank. So
fantastic.
And that was maybe 8 years ago, something like that. That was my first big plaster experience, and then I think we've gone more towards plaster because that's some place where I feel like you can really make a lot. You can hit a lot of the sweet spots of performance and aesthetics and just the feeling of a space. You can do it on just about any building, and we've dabbled in whole natural wall system construction. We've done some compressed earth masonry projects. We've worked on a bunch of straw bale houses doing the wall system, and we've done everything from sourcing local cedar that was and pine from the fires in Bastrop and putting that to good use in screen room constructions and additions to high-end plaster work on multi-million-dollar custom homes, and a wide spectrum of things. Whatever we could put what's here to good use. And,
what's here around us.
Right,
Yeah.
right.
So that is the theme for today, is to talk about low embodied energy materials. But you did touch on the construction industry and that juxtaposition of, the market forces versus what's here, right? So, what's available to be used for construction is largely irrelevant today. Right?
Oh, yeah.
What's available are trucks and shipping containers and materials that move around the world, and
venture capital.
I'm not going to veer into this any farther, so I'll just leave it at that. Other than to say that for professionals like you and companies like Positive Energy, that is the existing industry. That is the market norm. And do you engage with it, or do you turn your back on it and try to create a new industry? There's a fundamental tension there.
Yeah.
And so we're currently in the mode of trying hard to engage with it, trying to educate.
Yeah, I mean, I often describe it as, for us, like we're constantly in this iterative process of trying to figure out how to interject ourselves into the conventional workflow of green building.
Yeah, and hence this podcast.
Yeah, yeah, totally.
I'm seriously. Often I'm surprised by what people don't know. I mean, obviously, I don't know if you know, but Positive Energy is really all about mechanical systems for the most part. I shouldn't say that. Positive Energy is about everything, but the mechanical system understanding of our society and the willingness to think about it and engage with it is abysmally low, generally speaking. People don't know, they don't care, and so the mechanical system world just stays kind of stuck with static processes and systems.
Static pressure, too.
And high static pressure, yeah. We've joked about the hegemony of enclosurism. Like the hegemony meaning it's getting all the bandwidth of the room, and everyone's talking about different enclosures, and it's like, okay, if you live in Austin, Texas, and you're only an enclosurist, well, you're going to have a lot of heat and humidity. So that's positive energy. But the point being, getting back to the commonality, it is that you need to work on these high-end custom homes to have people know you exist, and then what's really happening is human caring. People care about what they do. People care about what they know. Even a production builder, right? He or she cares about their family. This is a way to produce a livelihood, and so ultimately
Exactly.
I'm upbeat. It's going to work out.
Yeah, and I think what you hit on, like caring about what they understand, I mean, that's a big part of the work, and also the reward of what we do is, I've always felt that people are generally just disengaged and detached from their physical reality, and we just kind of live in our heads and in our to-do lists and our very, very overly busy lives, and it's really hard to find peace and quiet and a sense of satisfaction in our home lives a lot of times, and in our work life, and things like perceived indoor air quality. You may not care at all about that, but when you walk into a space that has really good that's functioning, the fabric of the building is functioning well, and that's comfortable in the way that human habitation has a natural affinity for, it feels different. You feel better, and it's like noticing that working in these buildings for a decade or whatever, it just has become more and more clear that we need to help people reconnect, just like we do with nature. People need to reconnect with nature. They need to experience dappled light that moves a lot, and they need to, and those things are really important for even productivity in an office space. Lighting can really affect productivity. That kind of thing. We've got all this evolution backed up, building these brains that help us process the world around us, and then we've just totally compartmentalized that brain in this weird
Flat,
sterile,
rectilinear, white walls,
it's totally sterile
thermal
box.
blandness,
and it's not satisfying. It's consumerism on a scale that is destroying the planet, destroying our personal lives, and it's just kind of unnecessary if we're willing to pay attention to what is already here and what how we feel about it, and learn the stuff that we need to learn about it. I've found that high-end architect designed custom houses, those are the people for whom the narrative of this material came from here. It's good for me and my children. This building can go back to the earth without any harm being done when we're done using it. all those things.
They're receptive to that.
Yeah, they're receptive because they're already paying attention to the world around them in a way that there's a real value in that. Unfortunately, there are very, very few people who value that stuff, so it's hard to find. Most of the industry is dominated just by efficiency and cost and price per square foot, and especially when you get into the general contractors and their subs and how that whole thing goes down on an actual job site, there's just very few opportunities to do any real thinking.
Schedule and budget are king, and it's hard.
Yeah.
And well said. I'm trying to veer us away, but this is really, really rich stuff.
You gotta bring me in whenever.
And it's really important what you said, and we have said on the podcast before that ultimately we want something out of life that's psychological. I want a good experience of life, a positive experience of life, and so that's psychological, but we can't ignore biology, right? So that, and this idea that health is the new green, indoor air quality becoming important. And I really think it is a trend to say, wait, I have this body. I'm pulling this air into this body.
It's all that I am. It's the stuff I put in it, right?
Yeah, exactly. And it's the dominant intake. So, okay. So those of you that might have wondered if this was the building science podcast or the building philosophy podcast, but so on a day-to-day basis, you're doing things like natural clay plasters and natural lime coatings.
Lime plasters, lime renders, local clay bound materials. So for
local
work,
clay, not even...
Yeah, and that's a big thing. There are a lot of bagged products. American clay is kind of the most popular one, and they're great products. Very, very thin, coatings, more or less like a trowel on paint.
So what do you do with that's different?
Or
do you do that as well?
We have done American clay projects when it was appropriate for the task, but you can do amazing things with the clay, the spectrum of naturally occurring subsoils that we have here.
In Central Texas.
In Central Texas, right. So if you go, east of the Balcones Fault out into the area of Bastrop and south of there, you get a lot of this really red, rich iron oxide based clays and subsoils. Those tend to be, sometimes they're a little more expansive than the stuff that we have west of town. But west of town in the hill country, you get a lot of limestone as the parent material, the parent eroded material. Caliche bound up in the matrix of the clays, and they're just very different working characteristics of those two types. You can blend them, you can use them for different types of application.
How thick would they be on a wall, or could they be the
whole?
whole?
This is really interesting from the building science perspective. All the research that I've seen, the effective depth of an adsorptive material like clay. It's a hygroscopic matrix, and it's
that was with a D, by the way. Adsorptive.
Adsorptive, right? It's a thin film on the actual structure of it. They can absorb a ton of moisture from the air whenever there's big spikes in relative humidity, and they can re-release that out. And generally, the tests that people have done are on 8-hour and 24-hour flux cycles. And that's because of patterns in, people's
schedules.
Living. Yeah, right. Showering and cooking and that kind of stuff. And the effective depth of plaster, where that humidity is being absorbed into the thickness of the clay plaster, generally is thought to kind of max out for a 24-hour cycle at no deeper than, a centimeter and a half, something like that.
Really?
But it gets pretty deep into the wall, even in that 24-hour cycle. And then if you're talking about yearly cycles, you can go all the way up to, I think, 400 mils, or the kind of general consensus that in a lot of climates, that much unfired clay, masonry, or plaster skin, or however you're doing it, floors, depending on the finish, can actually buffer an entire year cycle of both interior conditions and the outside.
So by buffer, just to make it clear, you're referring to hygric buffer, controlling the moisture conditions inside the conditions.
Right. We're aiming for human health, right? Which is respiratory health. What's that, like 50 to 60% relative humidity seems like the sweet spot for limiting mold growth and allergens, all that stuff, right? Clay does that naturally just by being on the wall, taking the spikes of humidity out and putting it back in when it's dry, right? And so you just get all this added performance from that thickness. And one of the
And
reasons...
you said roughly a half inch, slightly less than a half inch is maximum on an annual
effective.
basis.
Well, 400 mil on an annual basis, if you're trying to do like a whole structure, model for it, that's generally where... This is all like pretty fringe science too. There are, maybe 12 or 13 good university-based papers that I've seen. There's not a ton of research on it. But generally, for our applications, we think like a 1/4 inch thickness over drywall, over painted drywall, just you're in an 8-hour cycle is probably only getting 5, 6, 7 mils depth. It depends on the pore structure of the mix and everything too. But you basically can't like steam up a mirror in a bathroom if there's clay plaster in there. Even a small amount, couple square yards of it, makes a big difference. And then overall performance, like heating and cooling, that's even less well understood.
How much, say we did a 1/4 inch, how much mass is in a 10-foot square wall, or how do you characterize it? Is it per square meter, per square foot?
Yeah, are you talking about
the weight of the clay, yeah.
Oh, the weight of the actual
And then how much
clay.
water, if you know that one too.
Yeah, I mean, generally the water ranges, the tests that they've done, they call them step response tests. And it's in a controlled box or whatever, and they have different types of material. And usually they do, the metric is grams per meter square of adsorption. And most materials are like minimal. Drywall and paint and finished wood, anything that's sealed up, basically is not doing anything, maybe 1 gram, 2 grams. You get into unfinished wood, softwoods, especially if there's any ingrain exposed, you start seeing elevated amounts up to 15 grams per meter squared. Clay comes out, clay plasters, depending on what you put in them. We formulate all of our own mixes using local clays, and we add a lot of times cellulose fibers, both for controlling shrinkage and tooling, aesthetics and stuff like that, but also because having that cellulose fiber does increase the amount of humidity that it can absorb.
Nice.
Generally the tests come out like between 40 grams per meter square and 65 grams per meter square.
Wow.
So it's a lot of moisture that can. 65 grams is it's a significant amount of water if you put it in a
454 grams is a pint.
Right.
Right. So
if you coat a house in this, you're talking about a fairly large amount of enough that you can measure the weight difference of the structure. That's how they do it in laboratories.
Yeah, and that's per square meter. And so
that's per square meter.
That's roughly, I'm trying to think of it. It's like maybe a shot glass.
Something like that.
A little bit more, maybe. But per square meter on a wall, that's a lot of moisture.
Yeah, and only pulling it out of the atmosphere, right? We're not talking about you want to keep liquid water away from clay plaster completely.
I was gonna ask about
I'm just realizing I've never had the opportunity to plug my uncle's website before, but he's a soil scientist who goes by the name Dr. Dirt. So
Dr. Dirt.
If you really want to get into some interesting stuff about soil, his name is Clay Robinson.
Nice.
And you might know him from his History Channel debut when he was speaking about the American Dust Bowl. Phenomenal show. Anyway, he's probably not listening to this podcast, but maybe we can all go give his website the Building Science Podcast Hug of Death.
What is that website?
drdirt.org. Doctor all spelled out.
Oh, and while we're doing plug,
and I'll connect you with him too.
Yeah, I would love that. Actually, a big part of using lime as a stabilizer for clays is understanding that electrolytic solution of high alkaline.
You guys will have some fun conversations.
Yeah, cool.
Wow, I'm
get into that.
keeping it at a lower level. So, but while we're doing website plugs, what's yours?
Earthboundbuilders.com.
Yeah, very good. Earthboundbuilders.com.
Straightforward.
I really want to explore this, and I think a lot of listeners are very interested in these natural clay plasters. So there are some available bagged products.
Yes.
Can those be put on in these 1/4 inch thick layers as well?
No.
Or are they incompatible with that process?
Generally just cost prohibitive, and of course,
cost prohibitive.
Yeah, well, like a bag of American clay. I haven't looked recently. I don't want to. It's a great company. I don't want to say anything against them, but generally it's like a credit card thickness that people are putting on. So very, very thin coats, and you can add
and how much
a
would that get
mix
per square meter? Do you know?
I have no idea. Somebody's, I'm sure, at American Clay has done tests for that. I bet if I got a hold of them.
Okay.
But they're not. We're kind of the competition to that. There are a lot of people from the world of natural building, which is, I should say, is this own like subculture of deep green ecological building, of which we participate in, but we also kind of straddle the weird liminal space between green building and natural building. A lot of people from natural building make their livings doing plaster work and custom residential settings, and that's American Clay's sweet spot. So I don't have anything bad to say about American Clay. It's a great product, but it is a very thin coating. It's mostly an aesthetic thing. It will increase, I'm sure, hydrate buffering, some.
And there's also the VOC absorptive.
Yeah, passive removal materials. That's a whole other thing with clay that is super fascinating, and we're just kind of just getting into it. I think they're actually maybe doing. So I did some work at UT, right?
Dr. Corsi, yeah.
Okay, I have not met him. I know that was going on because I did a workshop through the architecture school with their material lab at UT, which is another cool resource, and we've done some mock-ups of different wall systems and stuff for them to have on display for gallery showings and stuff.
But we don't know the results.
Yeah, I have not followed I've been trying to build my own house and
right, that's
do
a whole other
jobs
topic.
Right, so I don't know where that is at right now, but there is a lot of promising research, especially like mitigating the effects of ozone and creating all the, what are they, aldehydes? That are the toxins?
Yeah, ozone's a very dynamic molecule that takes other molecules apart.
Right.
Which is great if the other molecule is an indoor air quality pollutant, but it's not great if it's the surface of your skin or your couch or something like that. So.
And carpet, is notorious for.
Yeah. All right. So, but back to the clay plasters. So, the thinner is not better. Thicker is better.
Thicker is better for high grade.
Thinner is more common, and then if you think about back to their initial discussion in this conversation, in terms of market dynamics, right? A bagged product that's consistent in applications.
There are drywall finishing crews in Austin that do the bulk of the American Clay work these days.
Interesting.
And it's interesting, kind of evolution of the product being available to green builders. It was like the realm of specialty artisans, and then it gradually has become, the race towards the bottom line or whatever. And I think that American Clay has suffered some from that as well, just because the quality of the applications has gone way down. But it's, our approach to it is that we have beautiful clays, everything from deep, dark reds to very light, kind of
creamy,
yellow,
brownish gray or something.
Warm cream colors available here at basically road base production sites where they're just digging up big veins of clay and stuff all the time. TDS, the dump, is a good source for clay too, because they're constantly excavating huge amounts of earth, and a lot of that area that's maybe why they chose that area. There's a fairly thick bed of clay, which is good for sealing in toxins and things like that. So,
wow, I never thought of that. Choosing a site for a landfill.
Yeah, I think that
based on encapsulating toxins.
I don't know that that's their story. I know that
it may be undesirable land too.
And I should plug Kendra Welsh and Clay Sand and Straw is the name of her company. She's a natural builder in Austin she's a Rice trained architect and does everything from custom designs through the complete construction of the building. We don't.
Fantastic.
We stay out of all of that type of dynamic. We try to be specialized subs and do artisan installations and really focus on the, making these resources available and practical in kind of the normal workflow. But if you have raw land and you want to build a completely natural home on it, Kendra Welsh is just amazing.
That's awesome. That's exciting. Thank you for plugging that. And would she have mechanical systems on that?
Yeah, she does, I think, various things. I mean, I know that they've built residences that were unconditioned.
Okay.
And you do that by having a ton of insulation, very thick walls, tons of thermal mass. All your glazing is oriented to maximize, seasonal changes, all that stuff.
Capture prevailing winds.
Right. Passive design, from the 70s basically is the kind of guiding principles of the natural building, that quote-unquote world that I was talking about, which works very well. Depends on your patterns of habitation and comfort level and stuff like that. But generally, they just have much smaller mechanical systems.
So getting back to what we're talking about these walls. So far you've talked about the whole wall is basically a mixture of clay and rubble and rock.
That's a unique project.
And then
that's
thinner coatings, but they're more like between 1/2 and 1/4 inch.
Yeah.
And then what's mainstream is this credit card thickness. All of those will have, to the degree of that there's clay present, they will be a high grit buffer. They will absorb and release moisture, and they will be able to trap VOCs in their structure. Also, the mass is going to increase, so that means the surface temperature is stabilized. And as we all know from the podcast, from other ones, your dominant experience of a space thermally is in fact the surface temperatures around you. It's not the air temperature. So you are doing, what is it you're doing? You're not doing the credit card thickness. You're doing this 1/4 to 1/2 inch thick.
Yeah. Well,
typically, or you do a lot of different things.
We do a lot of, that's part of the problem.
Pretend there's a typically.
We do a lot of, so typically, if we were to come into a space like this, we would be, looking at the trim reveals and trying to figure out what the dynamic of the actual application requires of us to consider. But the more that we can get in, the better. And the deal with using local natural materials is that we buy this stuff for $20 a yard, $40 a yard, rather than $80 or $100 a bag. There's almost no material cost to any of it, but there's a lot of knowledge work that goes into it, and there's a ton of
processing and labor,
brute labor that has to happen to make it work. And
incredible.
That's my reality. Is I spend a good portion of my bandwidth on this kind of higher intellectual conceptual stuff and aesthetics, but the reality of the day-to-day is just it's wet work. It's wet, essentially masonry work, so it's messy and it's a lot of dust in the dry materials, a lot of shoveling, a lot of screening, a lot of physical labor involved in making it happen. So that's where the price per square foot and the workflow issues on conventional job sites and all that stuff comes into play. But generally, when we do things like retrofitting or remodeling projects, we can just process all the materials off-site, come in with ready to go, put it in the mixer. We do a special priming treatment over painted drywall to make sure it's not going to get soft or delaminate or whatever.
Okay, I want to get onto the lime plaster, but I want to do a few more quick topics.
1/4 inch to 3/8 of an inch, something like that.
Good.
Max.
So let's try to go through a few questions, relatively focused answers.
Sorry.
Ceilings are okay? No, sorry, man.
Ceilings are more challenging for all the reasons that finishing ceilings are more challenging.
Because of gravity, generally.
Yeah, right. It's harder work, but it's a great place to put clay, because you're not going to have any problem with water or cleaning or whatever. So generally, when we're looking around above backsplashes in bathrooms, ceilings, the upper half of the wall, those are like all the low-hanging fruit for packing these really high-grade absorptive materials in.
And then winter, cold, dry conditions, does it become more friable?
No.
Dust entering the space?
I've never noticed any kind of change based on the climate to the actual material performance.
Okay.
Most of the kind of considerations are about the wear and tear, because it's a softer binder. Clay doesn't have a chemical set. It's not like Portland cement stucco or anything like that. So you can mechanically erode it. If you gouge it with a chair back or something like that, it's going to show the wear and tear. Of course, all surfaces get wear and tear, and it's a very easy surface to refinish, to patch. I often go back to projects that we've done and spend an afternoon, 2.5, 3 hours, just doing a whole 5,000 square foot house, just, going around in quick patches on stuff. And people can learn to do that themselves too, but it's very easy to rework this material that's already on the wall. So.
Yeah, I was about to ask, that was my question there, is color consistency. Mm-hmm. So when you're doing a patch, are you kind of harvesting from around the patch and smearing that material in? Or?
We actually save cookies of all the mixes that we do on big projects, so that we usually leave those in the basement or attic or whatever.
So you leave the client some cookies.
Yeah, we leave them some material for
to make sure it matches.
And then
there will be variation around as you move through a building, right? Because you're using this natural material. Or
it's amazing, and we refine these things over. People have been doing this for a really long time, so there's all kinds of strategies for keeping things consistent. But we also add pigment to the lighter clays. I mean, we use all kinds of natural earth oxides as coloration. There's other additives that are completely natural. Prickly pear cactus makes a pectin when you soak it. It's like this mucilage that has a bunch of enzyme, long protein molecules in it, basically, that when you add it to the plaster makes it more plastic feeling as you're working it and seals it up a little bit more. So there's all kinds of things we do to add to.
That's so cool.
Yeah, and people have traditionally used.
The petrochemical industry is not liking what you're saying here.
Like
Prickly pear cactus, what?
Yeah.
Yeah.
People traditionally, for floors and walls, they used like livestock blood and dung and wheat paste, flour paste, things like that, gluten chain molecules, right? Anything that has like big springy molecules in it works great.
So you've done floors as well?
We have done some floors. Yeah, I've worked on a bunch. I've worked for Kendra's straw bale projects. We've done some floor work for them, and then there's a big compressed earth block project out in Wimberley right now that has a large, I think it's like 1,500 square feet or something like that. Pretty large section of earthen floor in it.
Awesome.
Stephen working involved with that one? Do you know
he may have been an engineer on that project. I don't know. That's not who I know from that project, but we know the client side of things in that project.
Okay. Wow.
Stephen gets around a lot, obviously, because of his connection to earth and building.
The last question on clay plaster, if you give us a range of prices.
$4 a square foot is pretty doable for most remodeling.
And that's not per square foot, like a 1,500 square foot house. You mean per square foot of walls?
Yeah, if we're doing like a single room in a house, or it just depends on the scale, obviously, right? So it goes from everything from, if you're working with a straw bale wall system, obviously you're going to have places where the thickness of the materials, you got to put 4 or 5 coats on, and just to manage the working characteristics of it, and you're getting thicknesses of 1.5 inches, 2 inches deep into the wall system between the finish and the interior of the skin. So obviously that's more expensive. Those are more like $8 a square foot for the type of. But that's really, I start considering the plaster skin as part of the wall's assembly in a much more like intense way. Much more, it's part of the way the wall actually is designed to function from the get-go. So it's not a finished material in that case. It's, you have to think about it as one of the structural and performance. It's the air barrier on the exterior.
Yeah.
It's the vapor control layer.
That's what we'll talk about now. Talk about lime plaster. Before we do a lime plaster, let's do a little philosophical break, because I'm remembering being in a lot of cob walls and earthen buildings, and I'm also remembering hearing architects and general contractors and thinking about the walls. Let's just say, and the walls have some natural curves and natural texture to it. They're not perfectly straight, and yet there are architects and builders that are just like, this sight line has to be dead on straight, and completely flat. We as a society seem to take that as like the pinnacle of my craft is how plumb and true I can get a wall. And yet I know, so I used to do some pattern recognition when I worked for the university, and we talked about high fractal content scenes. High fractal content scenes. High fractal content scenes. High fractal content scenes. So like you said, dappled sunlight, waves, trees. fields. Versus low fractal content scenes, which are a lot of rectilinear right angles and flat surfaces. And low fractal content scenes being strongly associated with depression. They did some studies with inmates, actually. It's kind of sad, but they're seeing a lot of low fractal content scenery.
Absolutely.
And yet, so here we are, we go into the
Hospitals.
highest end hospitals, exactly. So we know that biologically we respond to high fractal content positively. And yet, the pinnacle of architecture in some ways is like flat plumb, like low fractal content.
It's
What's
supposed
up
to be
with that?
uncomfortable. I mean, that's
It's supposed to be uncomfortable.
If you talk to a modern, someone who's really into modern architecture, the philosophy behind that is that the human occupant is it's like creating. It's actually crafting a fairly sharp, abstract,
Interesting,
like, harsh environment for the occupant to then create within, put a piece of art
so
on
it's
the wall.
stark.
Yes, it's stark, right?
Yeah.
It doesn't have its own character and its own life. And you're not in the constant feedback loop of kind of, like you said, those high fractal patterns, which I take to mean like basically the scale of if you look at 1 square inch of it, the differentiation, the visual and sensible differentiation in that 1 inch is going to be relatively similar to a large chunk of the wall or even the whole building. That fractal relationship between scale. And you get that with natural materials. These materials are, generally prized for just being naturally beautiful. They have a lot of character. They have a lot of movement and variation of aesthetic in them. So
are you challenged to make them flat? Excuse me, interrupting.
No. You can do that, right? Like a drywall substrate is flat already. So, if we came into a building, we would flatten these walls just because there's that much movement from the settling of the building and stuff.
This 100-year-old building that we're in,
Yeah, right. The walls would end up probably reading a little flatter and a little cleaner.
So you don't purposely try to put some character in and some
I leave that up to the clients and architects.
Okay.
So they
you can go either way. Okay.
Yeah.
That's good to push back, because I was assuming it was implicitly more variation in your product.
Yeah, quote unquote natural building is generally the aesthetic. If you just Google natural buildings, you're going to see a lot of very kind of hippie-ish, undulating, rounded corners. Lots of, and there's a lot to that, but that's obviously not what most people want. And I'm no place to decide one way or the other. I think my inclination has gone more and more towards just hitting kind of the average, of what people are comfortable with, and then, like you said, with the fractal patterns, offering all that differentiation and the aesthetic richness or whatever in the materials themselves, rather than just like the shape of the building or the. And I think it's less cluttered, less busy.
Miguel and I were in Houston, I guess it's about a year ago now. We saw this speaker, Ann Sussman, and she's at, I'm not going to know where she's at. She's at, I think, MIT, some pattern recognition lab, something like that, something to do with neuroscience. But she has talked a lot about the mental disorders behind modern architecture, about Corbusier having autism and being afraid of seeing a face. It has to do with when we look at a building as a mammal, we're naturally looking to see a face. But then there's certain people with certain personality or psychological disorders where they don't want to see faces. They're not good at eye contact, like think Rain Man or something. And these people design faceless buildings. And oh boy, was it provocative at an architect's conference. Yeah, we should try to interview her, Miguel.
It sounds good.
That'd be a good one. All right, so last topic. I was tempted to make your home the last topic, but we'll save that. Let's talk about lime plaster. Again, a topic that I don't think the petrochemical industry is happy to hear about, and not that we're going to end their hegemony.
In Portland.
In Portland, yeah, in the cement industry, yes, SEMA.
Hardy.
So what is natural lime plaster, and where is it used?
So lime is the binder so a plaster mix or a render or mortar or any of those different kind of categories is basically a calcium hydroxide binder. So it's which I'll get into separately if you want me to. But it's basically the lime is acting like in stucco. Portland cement is the chemical binder. Lime doesn't have the type of chemistry and chemical set characteristics that Portland cement does, so obviously it has to be treated differently. Different types of applications are appropriate for it, and I don't have anything against Portland cement,
Portland cement,
as a
they've had to
statement.
heat it. They've made an anhydrous material by baking out the water out of it.
And you do that with lime as well.
That's
the way
what
lime is produced.
Slake it.
Yeah, lime. So lime starts as calcium carbonate. It's just limestone. Lots of different types of that naturally occurring, and then you heat it to about 900 degrees centigrade, something in that range, like 1650 or something like that Fahrenheit.
So you can do that with a normal fire.
Yeah, we're building a little clay kiln right now, actually, to try and fire some for this project.
Awesome.
See what happens with that. This would be the first time I would ever have created my own binder. There's a ton of lime being produced in this area because we just have a lot of limestone.
Yeah.
So some big international players have manufacturing facilities in New Brunswick, and then there's local places as well.
I didn't know that. So internationally, this is a lime producing region.
This is kind of the hub for lime production for this region of the southern United States.
Okay, so not internationally.
But the companies, the conglomerates that own that particular manufacturing is a global corporation.
Okay,
so
okay.
There's big business in lime, and it's used in a lot of different situations. It's used in regular stucco work as well as a plasticizer primarily, and to increase permeability. People even get into that with stucco. Most of the time they don't. But basically lime mineral matrix is just aggregates that are well graded from whatever your largest size you're going to, which is defined by the application, whether it's a mortar bed that you're trying to get a 1/2 inch thickness, you need a certain size sand, maximum granular size to get the type of load bearing you're gonna be aimed at. And then for like a plaster, it's gonna be a much wetter application. It's not gonna be as thick and oatmeal-y as you're putting it down, so you got a lot more water. A lot of the lime is in suspension. That changes the way it works. There's just you basically tweak all the independent parts of it, which are generally some well-graded aggregate, lime as the primary binder, some sort of fiber is fairly common especially for plaster applications, just to increase physical performance, and to be able to build larger thicknesses up, and water, and you're creating this highly caustic, very high pH plaster material that as it dries out, it's going from that calcium hydroxide, which you've created by adding water back to what you create once you've burned all the carbon dioxide out of the original calcium carbonate. So it goes calcium carbonate, you heat it up, it blows off a bunch of carbon dioxide. It's at that point it's mostly calcium oxide. Then you take that calcium oxide, which is known as quicklime, you add water to it, it turns into calcium hydroxide. You put it on the wall or in the wall or whatever. As it absorbs carbon dioxide from the atmosphere as it's drying, it turns back into calcium carbonate, forms calcite crystals, all through the matrix that kind of bind the sand particles together. Yeah, lime is basically the cornerstone of all civilizations' building practices up until 100 years ago. I mean, basically everything was done with lime as the primary binder. So any building that was built before, like mid 1700s doesn't have Portland cement in it. It has some naturally occurring. Oftentimes, limestone will have some of the chemistry that Portland cement kind of creates, naturally occurring in the limestone parent material, and you can harness that to create some of the same hydraulic characteristics. And that's pretty common. Roman cement, but everything, all those old,
because volcanic activity could dry out, could create anhydrous materials. Is that
yes, you can add pozzolans to the lime as well. That's a whole different thing. You can actually use volcanic materials or like calcined clays even. If you lightly burn clay, this is very common in India. They made tiles especially for crushing up and adding to lime mixes in order to create that kind of chemistry. And there's a lot of different sources, natural sources, for pozzolans, which is the type of chemical that you want to add to the lime to create that hydraulic set. And when I say hydraulic, I mean it doesn't need to absorb carbon dioxide from the atmosphere in order to get to its working strength characteristics. It can actually just use the water that's available in the mix to create a binder like Portland cement does.
Okay, and just so people know what we're talking about, this natural lime plaster, it's a stucco substitute.
Yeah, basically. So on my house, I'm using, it's a conventional frame and dense packed cellulose insulation, a bunch of clay plaster skin on the inside, which I'm doing in a way that's not very conventional, but
you're not doing sheetrock with that.
No, I'm keeping sheetrock out of it altogether.
You have a screed, or what do you do on the inside?
Yeah.
All right, let's talk about your house as the last.
Well, but the lime part of it is I'm basically creating a ventilated rain screen assembly, just like you would with.
Really, you're doing ventilated rain screen like stucco assembly.
Yeah, man, lime. So all stuccos are reservoir claddings, right?
Yes,
they all hold a lot. And it's one of the characteristics we actually love about lime is fairly high capacity for moisture, right? So it's very porous matrix, and it performs admirably as the outside skin of a building if you aren't just allowing the sun to drive all the moisture that accumulates into it into the inside of the building, right? And you have to be really careful, the way you design air barriers and the way you think about vapor diffusion in a wall system when you're using lime as your primary cladding on the outside. But you really have to do even more careful design if you're using conventional stucco, because those materials also bring a lot of moisture inside of that cladding, but then they don't let it back out.
Yeah.
And lime, obviously, it almost throws moisture off in its static state, the way the chemical charge, the electrical charge of the chemistry and everything is. I don't know very much about that, but it basically self-dehydrates. Like magnesium oxide is famous for that as well. And there's people that are going more towards magnesium oxide than the calcium oxide, which is the basis for the lime binders. But we just have a ton of limestone here, and we make good lime here, and it's a great binder if you design the assembly properly, and it's beautiful. It's easy to work with up to a point in the year. It is temperature sensitive, and you do have to control the cure fairly carefully, so it gets a little bit more expensive the more work we have to do to protect the initial week or week and a half.
Is it worse when it's cold or worse when it's hot?
Yeah, we don't get cold enough here usually. You don't want it to freeze with any moisture in the wall, in the matrix. But you do, it can...
So when you're doing it in the hot, you're constantly having to rehydrate it.
Yeah, you're out there until sundown some days, misting the wall. We hang burlene, which is like a burlap with laminated, poly on the outside of it that won't let air through and traps all the moisture. You wet down the burlap side of it, and it keeps lots of moisture, 6-8 inches off the surface of the plaster. There's a lot of, again, that's why the knowledge work part of it makes it not very practical for modern construction workflows, but for maximizing performance, it's a great air barrier. There are a lot of things about it that make sense in our climate as the first line of defense on the outside of the building. You just have to be really careful about the whole assembly, how much moisture storage there is, what the evaporation dynamics are, and drying and all that stuff.
That's beautiful. So, I think each homeowner should build their own house. And that,
yeah.
I mean, I've built mine, and it's a great experience to do it and live in it. And
yeah. I mean, it's a huge pain in the...
It's also a huge time sink, and it was financially rough. But, okay, so how are you accomplishing this ventilated rain screen?
It's pretty conventional from the sheathing out. It's just replacing the stucco with the traditional lime mix. So it's a zip system, liquid apply flashing where appropriate.
Okay, so quite traditional. Okay.
Yeah, I don't. This is just this one kind of hybrid. It's a small building. It's the first phase of what we're planning on doing on the property eventually, but I really have seen more potential for using these natural materials in more conventional wall assemblies. And the more I understand about the actual building science of it, the more I get drawn into where in a conventional assembly can we interject this?
Yeah, absolutely.
This material.
Beautiful.
And basically, you got to be careful of a few things that are common in stucco. I think what I'm gonna use is the Boral drain and dry product, because you've got drying potential on both sides of that product, and you've got a pre-applied fiberglass stucco mesh on the outside. You have to be careful with lime with metal stucco mesh because it does hold a lot of moisture in there. It's a high alkaline environment. You can create rust problems and stuff. So
there's a Delta Dry stucco and stone is similar. Yeah,
you're welcome, Casella Dorkin.
Yeah, I like the ones that have the fiberglass mesh for sure. That makes sense for what I'm doing. It's faster. It seems like a workflow. I've never done that assembly before, but it seems like something that I could maybe find takers on in the future. So.
Yeah, I was curious how you were going to do the ventilated rain screen with all natural products, and I like the fact, but I bet you could.
You can.
I like the fact that, sort of philosophically almost, you're saying, well, how can I move what I do closer to mainstream construction and therefore get more uptake and early adopters?
I think there's a lot of bad juju in the natural building world because people have come at it from this very philosophical, back to the earth, kind of aesthetically driven.
You're either with
lifestyle.
us or you're against us.
It's very much. I mean, you can almost see a division in the generations of people that, pre-information age and post-information age, like the way people feel about it. And I think, because of that, there's been a lot of bad buildings built that don't perform very well, that claim they should perform well because it's all natural wall systems. And but there's lots of good uses for manufactured and highly engineered materials in buildings. There's lots of reasons that we want to be using those things. We just don't want to like that to be the only, like we still have legs. We don't need only crutches. We can like prop up the way the mechanical systems work and the way that a conventional wall simply works by using materials that are here. That also, lime is almost carbon neutral because there is energy put into it to burn off that carbon dioxide, but it also absorbs carbon dioxide back into it. So it's not completely carbon neutral, but it is much closer to being, kind of a sane, sustainable exterior coating than just about anything else on the market. Yeah. There's just so much less embodied energy in it. It can be scraped off and just put right into the ground when it's done. It's inert minerals, good for indoor air quality. It's great for,
And almost undoubtedly the indoor microbiome is being positively affected with that material.
Every hospital or like surgical room or in any place that needed to be sterilized for all of human history was lime. You use lime wash and lime surfaces on everything because antifungal, antimicrobial.
Yeah.
We did a Boy Scout camp every summer, and we had a latrine that had a little bucket of lime next to it. After you did your business, you're supposed to put it in there. One of the other effects of lime that we found out in that same Boy Scout camp was that if you place a very thin layer of it on the toilet seat, you can't see it, but whoever sits down next is going to get a little burn. We were bad kids.
Nice chemical burn.
Had a lot of fun.
Yeah, I was a Boy Scout too. I almost broke my arm helping to carry a friend of mine's cot up to the top of a pine tree.
Yeah, that sounds about right.
Wow, that was a feast of ideas, Brad. I'm so glad that you came in today to share with us. That's all right. And, those of you that are listening, by the way, just to show you how organic and natural this podcast can be, for various reasons, Brad came into the office today. We started talking and just said, hey, let's record this. So sometimes natural podcasts can occur on natural building. All right, thank you again, Brad.
All right, thank you.
Well done.
Stuff, guys.
And thank you all for listening.
Don't forget to share the episode.